preservation in health, because we all know that, when we bring children, they stay do things. This is Professor Hall, who is the director of the Centre for Injury Studies.
I'm not an orthopaedic surgeon, I'm an engineer, and so we have this collaboration between engineers and medics and scientists who are looking to advance rehabilitation, protection and mitigation. And I'll just remotely, from a distance, introduce... Spiros has been part of our work since 2008. We'll just say a few words and give you a demonstration.
We're working very close with military medics since 2008-9, since the height of the conflict. Our role is mainly to reverse engineer, if you will, injury. How does it happen? And if we can understand how it happens, we might be able to protect it and treat it. So a lot of the work that happens in here with all these machines is about actually creating insult or different insult to the human body in ways. For example, the lower extremity. So we created into the vehicle where we could test legs and see the effect of posture, for example, an injury. And we could also test things like carpeting the floor with things that now are deployed in vehicles that can absorb energy before it comes to the foot, if you want to.
It just absorbs the energy.
That's developed here.
It is not developed here now. We were tested, so we actually procured that work from BSDL, so we tried different of those things, and they decided which one is going to go in. Another machine that we use is just behind everybody. It's a long, essentially gun, or we can fire projectiles that are associated with blast, so things like this that come with armor. So this is, for example, soft armor. Or we can see at what velocity it will penetrate or not and create injury or not. And the last thing, so
do the existing flat checkers, do they pretty good?
They're pretty good, yes.
Which improve, yeah.
Correct. And some of these go to line vehicles, some of them go to line clothing. Correct. And one last thing is about combat boots. So 10 years ago we tested the combat boots that were deployed at the time. So the way we test them is with something dropping a lot of energy into the heel, because that's where we know is going to be the injury. So we could qualify those boots, but can we do something better about dismantling? So we have worked with them to create a bit of a bigger stout of which you will distance, bearing what put in it to absorb the energy when we step like this. So we're being clever in how we design to be able to absorb the energy. So that's what we put together as a demonstration. So George is going to press play and he's going to explain what's going to happen.
The machine's going to move up and use a combination of gravity and spring assisted to drop it really quickly to test one of the samples we've just seen. It'll start spinning up, and then once the noise stops, it'll drop. There'll be a very loud bang, and the specimen will shatter.
A loud enough bang,
Not bang.
but not too loud.
Thank you very much.
So this is just the spring system charging up, it's compressing it, and then once the noise stops, it'll drop down.
So 3, 2, 1. So we will pick it up from in there when the machine decides to pick it up, so you can see the damage. So we're hoping that this goes in bits and not your foot.
So, is this what you're working on at the moment?
Correct.
You haven't quite finished perfecting your real hands.
We have just about perfected it. The company is making the boot right now. We're hoping to launch the caps and the geometry of this, and also the way we have put the one after the other, so it creates.
And that would prevent
Correct.
the foot or the heel.
Correct.
So it's frequently heel injuries.
Correct. Both thin mounted and dismounted. Correct. And that is a severe injury because you can end up with a below knee amputation. You cannot fix the heel. You can fix further up. H might talk about that a bit more. But
It's damaged.
if it's damaged, it's damaged. Correct.
So have you been able to apply, have you got better kit than you do?
So I mean, a lot of this gets translated very quickly
Into
it's remember during the start we were very quick.
Yeah.
It'll be very quick.
Yes, exactly.
Because they are the ones actually that can make the difference, because they're what's worth it.
So have you got a list of really good companies that you work with that you know you can rely on for
We
the same field? Or is Yes.
Yes, I work in Spiros's lab.
Right.
2008, I started working on this with engineering and military medics.
So I graduated from the teaching amputation. So a lot of work that we've been doing is on the rehabilitation side, which you'll hear about downstairs. But part of that is to produce prostheses that are suitable for mass production in environments where perhaps the very expensive prostheses are not available and that are functionally effective. So it's mechanical and yet provides the same optimal functionality as you would have from the very expensive microprocessor controlled knees. Tested in these machines that don't just drop weight, they push and pull slowly to replicate walking, for example. And that's the kind of thing that we've done with it. So this has been tested for a couple of million cycles, representing a number of years of use for an amputee in this machine, just pushing it up and down. But we'll show you a little bit more downstairs. I need to hand
Do you
back.
have to get these specially made?
So this machine is actually it's powered by hydraulics. It can go very fast. It can also go quite slow. But the good thing about it is it can test things for millions and millions of cycles. And the interesting thing about these machines is, although we're testing whether or not this will fail after a million cycles, we have the equipment that we use to test. Yes.